Hello.
Good
Hello.
evening, sir.
Good evening,
Good
sir.
evening.
Yeah, good
Good evening.
evening to all of you.
Good evening.
Good evening.
Good evening, sir.
Okay, so we'll start this session in 2 minutes. Okay. By the time, how many of you have covered the week 12? Is it like everyone has covered week 12 concepts and assignment and all?
Yeah, we've done that. Even the mock also we tried.
Okay, great, great, great. So what I thought for today's session, like will not go in that much depth, right? Because we have discussed the lots of examples and all in week 11 sessions and week 12 sessions. So what I will do, I will quickly go through the basic formula and some idea behind every distribution. And I have collected some questions from week 11 and week 12, which we have asked, in previous terms actually. So what we'll do, we'll try to solve the questions. We'll try to identify what kind of questions is this or which concept is going to apply for that particular question and all. So accordingly, we'll get some flavor about like these kind of questions we are asking in your end term exam related to from week 11 and week 12. So will that be all right, or like do you want to something else?
No, sir, it's okay, sir.
Is it okay for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, all right. So anyway, formula sheet will be provided to you. Okay. So what will be the key thing we have to identify for that particular question, which distribution you have to apply? Okay. So let me share my screen. Is there any other session going on simultaneously, or is this
No, sir. No any session. Only one.
okay? Can you see my screen? Is my screen visible
Yes,
to all
sir.
of you?
Yes, sir.
Yeah, yeah.
Yes.
So what I'm going to do, I have collected the questions, okay, from previous terms. So I will just quickly go through the basic concept, basic idea. If you want to detail discussion about this, week 11 or week 12 concept, so I would request to you, you can simply go through the week uh, 11 and 12 open session. Anyway, I'm hoping you will get the idea from though, I mean, whatever the things we are going to discuss. Okay. So first thing is from week 11, in week 11 we have seen like some discrete distribution. Okay. So very first is called Bernoulli and binomial distribution. Okay. So what Bernoulli called? So Bernoulli means if you are performing any random experiment, right? Whatever the experiment you are going to perform. So for that particular experiment or for that particular trial, there are only two possible outcomes, right? First one is called success and second one is called failure. Yes or no? If you have success, we are denoting with 1. If we have failure, we are denoting with 0. Correct? And so, for once, let's say success probability is P, and for failure, probability will be 1 minus P. So far, so good, right? You can see
Yes, sir.
we have taken lots of example. Let's say you can say if there is any where you are interested only that particular student, whether he has qualified that particular exam or not. So you will be having only two outcomes, right? Qualified, not qualified, pass, fail, head, tail. So these kind of trials will come under the Bernoulli trials. Okay. And what is the expectation of, let's say x follows Bernoulli, then what will be the expectation of x? We know it is P. Yes or no? And variance
Yes,
of
sir.
x is 1 minus
One.
P
Yeah.
into P, right? I mean P into 1 minus P. Okay. So do not worry about these formulas. So you can see these formulas will be provided to you already. So variance is P into 1 minus P and all. Just uh, quickly revising these kind of things. Okay. So, and what about binomial? Suppose you have x1, x2 and all, let's say xn. Okay. These are NIID Bernoulli random variables. Okay. If I
Okay, sir.
have an IID Bernoulli random variables, so let's say I'm going to define a random variable, let's say x, which is collection of these n IID Bernoulli random variable. So these x1 plus x2 plus up to xn will follow binomial distribution with parameter n and success probability p. So this success probability is for each trial. Okay. So here x1 is also Bernoulli trial, x2 is Bernoulli trial, xn is outcome of your Bernoulli trial. So thing is that n represents the number of trials. Okay. IID means all trials should be independent and identical, and P is the success probability. Any doubt anybody till now?
No, sir.
Okay.
No, sir.
Sir.
So this is the binomial, right? So
No, sir.
example you can take, suppose you have tossed the coin 2 times. So for each time, like let's say you are tossing a coin first time, that will give you the form of Bernoulli. Second time, Bernoulli. But if you consider both together, means x1 plus x2, that will give you the binomial distribution. All right. So here, what is the expectation of x in case of binomial? It's n into. All right. What is the variance of x? N
And P
into.
into 1 minus P.
Minus.
One
Right.
minute.
So I'm not going to do this derivation, right? Maybe I think I have done in open session. Okay. Will this be
Yes, sir.
all right? Okay.
Yes, sir. Yeah,
So
yeah,
this
sir.
is some sort of idea about binomial and Bernoulli. So next question. So I have included the marks so that you will get some idea what kind of question, what is the weightage and all. So this question was, I think, from the last term itself. So you have to choose the correct options. My screen is visible. Are you able to read or
Yes, sir. Yes,
Yeah,
sir.
yeah.
okay?
Yes, sir.
Yes, sir.
Tell me which option should be correct.
Option A.
Option A. Okay.
And C.
C.
Option C.
Why not D? B and D. What's the wrong with B and D?
In B, it should be 0 to 1.
It should be 0 to
Yeah.
1,
Yeah,
correct? CDF is will always be like between and what about this D?
Discrete quantity.
It
Yeah.
should
Discrete
be
random.
Continuous.
Discrete
Yeah.
distribution. Okay.
distribution.
So A and C is the correct. So you can see within less than 1 minute you will get 2 marks. So there will you will get some sort of concept related questions also. Okay. So if you have attended the live sessions, or you have watched the lecture video and you have attempted the activity and all, you will be able to do these kind of questions. Okay. So any doubt in this question?
No, sir.
No, sir.
No, sir.
Move to next question.
So next question is okay. So next question is, suppose a random variable x denote the number of products that pass the quality control inspection in the factory independently with probability p is equal to 0.6. 5 of the products are randomly selected for the inspection. So what will be the distribution of x?
First
Sir,
option.
option 1.
Yeah. Option.
Why
Yeah.
First option.
why not option C? What is the wrong with option
It
3?
doesn't contain two
There's no
parameters.
n.
Yeah.
Two parameters.
There is no N.
No, forget about
Or-
n. So okay. How did you decide here x will be binomial
Also,
only?
it's Bernoulli. It's
Because
Bernoulli
they are
in the third
drawing 5
option.
products randomly.
Correct. So actually what here x represents? Correct. So option A is the correct. If you see, x is nothing but, let's say they are inspecting some 5 randomly selected products. Okay. So what is going on here basically, x1, let's say result of whether this product x1 will represent like product 1, whether product 1 will pass the quality control or not, right? There is only two possibility, right? Similarly for x2, product 3, product 4, product 5, right? So these are the, if you see the individual random variables, these are, if I will say xi follows Bernoulli 0.6, I is nothing but 1 to 5, then this is correct. Yes or no?
Yes.
Okay,
Yes,
sir.
sir.
Yeah, sir. Yeah,
Right?
sir.
Right? What here x represent? If you read x carefully, x denotes the number of products that pass the quality control inspection. So x is nothing but, and how many products they are inspecting? 5, right? So they are interested in some 5 products, right? Yes or no? So this will follow binomial with n is 5. And what is the success probability? 0.6. Is this clear?
Yes.
Yes, sir.
Yes, sir. Clear. It is
Right?
clear.
Clear to all of you? Any doubt?
No,
No,
sir.
sir.
Okay.
Yes, sir.
Hello, sir.
Yes.
Sir, what will be the statement in case of Bernoulli?
Yeah, I told you, right? So statement will be, suppose they are interested in each xi, individual product. Okay. Xi will, xi here, xi represents the, like, you can
Any
say,
product.
yeah, ith product, basically. I will be
Okay.
1 to 5. Okay. X1
Okay,
for the
okay.
first product, X2 second product, third for the fourth product, fifth product. Okay.
Okay, okay, got it, sir. Yeah,
Yeah.
thank you, sir.
Yeah. So by using the same information here, answer is given to you, but I want to, all of you, you will tell me how to solve this. So we got x follows binomial with 5 comma 0.6. So what is the question? What is the probability that at most one of the product passes the quality control inspection? So what is the, what should I write?
Probability of x is less than equal to 1.
So what is the meaning of at most one?
Less than
Less
or
than
equal to
equal
1.
to 1.
Correct?
Less than or equal to
less
1.
than equal to 1.
Correct? This is
Less than
meaning of
equal
at
to 1.
most one,
Yeah.
right? So this is
Yes, sir.
something we have to calculate. So this means what? And we know x is taking 5. That means what? X will take value 0, 1, 2, 3 up to 5.
Yes, sir.
Right? So what should I write? Can I write probability x equal to 0 plus probability x equal to 1? Would you agree with me?
Yeah. Yeah, sir. Yes, sir.
Right?
Yes, sir.
Now we know what is the PMF of binomial. I forgot to mention. So what is the PMF for binomial distribution? If you have probability x equal to x, then for this case, okay, let me rewrite. Suppose, give me a second. Suppose I'm saying if x follows binomial with parameter n comma p, then what is the probability x equal to x? It will be ncx p raised power x 1 minus p raised power n minus x. Yes or no?
Yes. Yes.
Right?
Yes, sir.
So what is the case here? We have to calculate probability x equal to 0 and probability x equal to 1. So what will be the case? What is the n here? 5. By using this formula, can I write 5c0?
Yes, sir.
And what is the p?
Yes, sir.
0.6.
0.6.
0.6.
0.6 raised power 0. 1 minus 0.6 raised power how much?
0.4 power 5.
4.
5.
Minus 5 minus 0, right? Plus,
Yes, sir.
for this part, I should write 5c1, 0.6 raised power 1, 0.4 raised power 5 minus 1, that is 4.
Yeah.
Yes,
So
sir.
5c0 will be 1, 0.6 raised power 0 will be 1. So here it will be 0.4 raised power 5. 5c1 is nothing but 5 into 0.6 into 0.4 raised power 4. Okay. So if you will solve this, okay, let's try to solve this. 0.4, I'm going to use Google Sheet so that we can do the calculation easily. So
It is
0.4.
0.087.
Okay, so next one is combination of 5c1 into 0.6, right?
Yeah.
Into 0.4 raised power 5. And we have to add these two cases, right? So summation of these two points, what is the answer? 0.087. What is the wrong?
0.087. So
1 second. It should be 0.4 raised power 4. Yeah.
4.
So 0.087 is the correct answer as we can see. So, okay. Is this all right? Any doubt?
No, sir.
No, sir.
So you are able to relate the concept with the question, and are you getting some sort of any kind of no
Yes, sir. I am.
confidence
Yes, sir.
and all? Okay.
Yes, sir.
Okay. Now third question is the probability that I mean question practice or so Prajwal, we are just uh, like I have collected some questions from the like previous terms. Okay, it's not like from the just I mean Jan 24 terms. I collected from some previous term, May 23, September 23 also, which include the concepts of week 11 and week 12. So we are just discussing the questions, how to apply the concepts of all the distributions. uh, like if you are going to read any question, then you should get idea what kind of distribution you can apply. Okay, so next question is so this question says the probability of a man hitting a target is 1 by 4, correct? If he fires 5 times, then find the probability that he will hit the target at least twice. So what kind of distribution you can apply?
Binomial.
Binomial. Why?
Yes, sir. Because we are repeating 5 times the Bernoulli trials.
Bernoulli tries. Okay. So because what he is doing, suppose x1 represents the, when he fires at the first time, right? That if he will fire at the first time, so there is two possibility. Either he will hit the target or not.
Or miss the target.
Correct. Similarly, if he will fire at second time, he will hit the target or not. Yes or no? Similarly, till
Yes, sir.
5, right? 5 times. Yes or no? And every time, what is the success probability? 1 by 4. If he is
1 by
unable to
4.
hit the target, so it will be 3 by 4. Yes or no?
Yes, sir. Yes, sir.
Right?
Yes,
So
sir.
here we are interested in 5 times together, right? And all are independent or not. Here it is not mentioned, but can you get some intuition? These are independent, right? Right?
Yes.
Yes,
So
sir.
what will be my x? X will follow binomial with n is 5. Success probability as 1 by 4,
Yes, sir.
right? And what is the question? What is the probability that he will hit the target at least twice? So what is the meaning of at least twice?
Greater than or equal to.
Greater than equal to.
Probability x greater than equal to
2.
2, right? So there is two ways. Either I can add I can add x equal to 2 plus probability x equal to 3 plus probability x equal to 4 plus probability x will equal to 5. So this will take a little bit time. Another approach
Yes, sir.
is what you can do.
Sir, can we take 1 and subtract the rest with x less than
Yes,
0?
yeah, the
So
same
x
thing.
less than
Yeah,
0.
Yeah,
so
yeah.
I can do 1 minus probability x less than 2. Since this
Yes,
is
sir.
the discrete, here equality sign matters, right? So can I do 1 minus x less than 2 means probability x equal to 0 plus probability x equal to 1,
1.
right? And what is the case
Yes,
here?
sir.
If you see 1 minus 0, so it will be, yeah, tell me what should I write? I will write, so you tell me. 5c0, then
1 by 4 to the power.
Power 0.
0. 1 minus p, so 1
1
minus p
minus
is
p.
3 by 4, right?
Yes, sir.
Rest for
5
5 plus
minus 0.
5c1. 1 by 4
1
is
by
for
4 to the
1.
power
1
1.
5. 1
3 by 4 is for
by
4.
4 to the power 4.
correct. So here you will get 1 minus, it will be 3 raised for 5 divided by 4 is for 5. And see, this 5c0 is nothing but 1. Something raised for 0 is also 1. And it will be 5 into 1 by 4 into 3 raised for 4 divided by 4 raised for 4. Okay. If you
Right.
will solve this, so 3 raised for 5 is nothing but it 27 into 9. So 27 into 9, it will give you 243. Yes or no?
Yes, sir.
divided by 4 raised to power 5 is nothing but 1024, and they are it, you know, like like 3 times, I mean 81 into this 5 also, right? We have to apply with this 5, right? So 81
Right.
into 5, it will give you 405 divided by 4 raised to power 5. So basically, what is the 405 plus 243? 648. So 1 minus 648 divided by 1024. If you will solve this, it will give you 376 divided by 1024. So you can
0.628.
see this is the correct answer. Yes.
Sir, won't this be just go to the solution which you just wrote? The first term that we found the probability of p is equal to 0. Here must it be power 4?
Where this one?
4 to the power 4?
Why?
Because the total probability is 5. We will subtract 1 from this.
No, I didn't get your question.
The formula for
See, formula is NCX p raised to power x 1 minus p raised to power 5 minus x. Okay.
yes.
All right.
So if you subtract 0, it will give you 5 minus 0 as 5, right?
Okay, 5 minus 0. Okay.
Here, if you see 5 minus 1 is 4.
Okay. Sir.
Understood?
Yes.
Okay. Yeah. Any doubt in this question?
Sir.
Hmm?
Okay. So what I did is I took this 3 to the power 4 and 4 to the power 4 as common in that bracket.
Yeah, anything.
And then did in that
Fine.
one. No,
Even
but I'm getting a different answer.
no, then there is a
Can you do in
calculation
that
mistake.
way?
No, there is then
Calculation
calculation
mistake
mistake you
happen.
are doing.
Like I tried two times, but I was getting different answer. I was getting 256 something in the denominator.
Taking 1 by 4 common.
No, not 1 by 4, 3 to the power 4 and 4 to the power 4. That.
Okay.
Yeah, you can take. That's not a problem.
Daily you check it.
See, if you will take common here, see that means you are simply doing some calculation mistake. See, 3 raised to power 4, 4 raised to power 4, right? If you take common, it will be
Yeah.
3 by 4
Yeah.
Plus 5 by
Plus
4.
5 by 4.
plus 5
Sir,
by
sir,
4,
we
right?
take common 3 raised to power 4
Yeah.
and 4 raised to power 5, sir.
Wait, 1 minute.
1 second.
3
So
by
it
4
will be
plus
1
5 by
minus.
4 will be
So-
2.
Hello,
So
sir, we can.
1 second, 1 second. So this will be 2, right?
Yeah.
Okay, so
So
let's do
see
this
here
one.
in
Yes.
yeah.
1 second, 1 second.
In
So
the
3 raised to power 4.
denominator,
So if you'll do, so this into 2, right?
no. So my question is, sir, yeah, numerator will change, but the denominator will be like 256, 4 to the power 4. So
See, even you are getting 256, right? So this you can cancel out, yes or no? What is the final answer you are getting? See, one smartest approach is whatever the answer you are getting, right?
yeah.
So you can simply do, see, correct answer is 376 divided by 1024, right? What is the answer you are getting?
Okay, so I'm getting 94 by 256.
See,
Yeah,
94
even
by,
I did.
That's the correct
you can
answer.
see, right?
Acha,
The
acha.
answer is same. See, this is this.
Acha, acha, yeah, got it.
What you can do, you can simply, cross check which
yeah.
answer is understood. Okay.
Yeah, got it.
Okay. Any doubt
Sir,
in this binomial part?
no, sir.
Okay.
Sir, like I was talking about the PDF of the session. Sir, when will I get that?
So I think first session should end up only after that I can send, right?
Okay, so sir, you will be sharing, right?
Yeah.
Okay. Otherwise,
So
Okay.
just a small doubt, sir, I want to clear that whenever we will get question that you have to find probability at least 2. We will not include 2 if we do 1 minus probability of x less than 2.
No, you can't, right? So at least 2 means x greater than or equal to 2, right? If I will subtract 1 minus probability, it should be x less than 2. It's a simple one is what is the probability of A complement is nothing but 1 minus probability of A, right?
Yes, sir.
So what is the complement of this part? Less than.
Less than, okay.
So you have to be careful if this is the discrete. If it's continuous, then this equality sign doesn't matter. Okay. In the case, in case of discrete, equality sign does will matter. Clear?
Yes, sir.
Okay. Yeah. So next distribution is okay. Anyone any doubt so far in binomial and all, or it's clear?
It's clear.
Clear?
It's clear, sir.
Okay.
Clear, sir.
So next distribution is
Sir,
called Poisson distribution.
sir,
So yes.
sir, one request, just put your laptop on charger. It is depleting very fast.
Oh, yeah. Thanks. Give me a minute, please. Okay, yeah. Thanks for info. Okay, so next distribution called Poisson distribution. So we have discussed I mean in detail what is the Poisson distribution. So Poisson distribution is nothing but whenever you are interested in like number of occurrence of a event in a given space of like interval of space or interval of, we saw some examples. So interval of space means, let's say you are interested in number of suicides reported in a particular city. So that particular city is nothing but you can consider as a space. Similarly, number of spelling mistake in a page of a book. So these kind of things, and then number of accident happening at a particular intersection of the road, let's say in 1 hour, something like that. So whenever we are interested in these kind of event, that comes under the Poisson distribution. Also, we discussed like if in case when we have binomial, right? So if n is large and p is small, then product of n into p, which is lambda, this should be finite. So we didn't discuss about derivation behind this, but you will apply the limitation property and all, you will get the Poisson distribution. So thing is that key thing is whenever I will say x follows, let's say Poisson distribution with parameter lambda, then first of all, what is the PMF for this? Anyone? E raised power minus lambda, lambda raised power x divided by x factorial, and range of x will be 0, 1, 2, and so on, right?
Yeah.
And what is
till
the
infinity.
expectation of x in case of Poisson distribution?
Lambda.
And what is the variance of x?
Lambda. Yeah.
Lambda, right? Also, you are aware about that this lambda can change, right? If suppose I have given some 3 calls, let's say per hour, for example, okay, then my question is in minutes and all, then you have to change this lambda, yes or no?
Yes. Yes.
Yes, sir.
Sir, I had
Sir,
one
in
doubt.
Poisson distribution, variance will be equal to lambda also.
Yes, yeah.
Yes. Lambda square, sir.
No, not lambda square. Don't get confused with exponential. In exponential, it's a 1 by lambda square. In Poisson, mean and variance both are the same.
Okay, sir.
Okay.
Sir, I had one doubt regarding lambda.
Hmm.
Like, sir, when you were explaining in the previous class, like, don't confuse your exponential distribution with this Poisson distribution. Sir, in both, it is lambda, right? But in the Poisson distribution, lambda represents the average number of event happening in a particular interval, right? While in the exponential, I don't know what lambda represents actually.
It's a rate parameter. I will come to that. Don't worry. Okay. Let me finish
Yes,
the
sir,
discrete distribution first.
Oh, okay, sir.
Okay. Okay. So this part is okay. Clear. Okay. This exponential, I mean expectation and variance and all. Yes.
Yes,
No.
sir.
Okay.
Yes, sir.
So let's see the question which has been asked in the one of the previous term. So if x follows Poisson lambda, so this is the information is given to you. you have to find the value of lambda for which this equation is there. Okay, by using this equation we have to find the value of lambda. So I told you that if x follows Poisson lambda, okay, then what is the probability x equal to x? I mean probability mass function e raised power minus lambda, lambda raised power x divided by x factorial. Yes or no?
Yes,
So
sir.
what is the equation we have?
Yes.
We have 3 times probability that x equal to 3 equal to 2 times probability x equal to 2 plus 4 times probability x equal to 1. Okay. Instead of small x represents the one of the value for your capital random variable. Okay. So instead of small x, we have 3, 2, 1. Yes or no? So what it will be? Can I write for this e raised power minus lambda, lambda raised power 3 divided by 3 factorial?
Yes, sir.
Yes or no? Similarly, 2
Yes,
into for this part
Yeah.
e raised power minus lambda, lambda raised power 2 divided by 2 factorial plus for this part 4 into e raised power minus lambda, lambda raised power 1 divided by 1 factorial. So far,
Right.
so good.
Right.
Yes.
Now, if you focus e raised power minus lambda, I can cancel from both sides.
Yeah, sir.
Yes or no? So if you see
Yes, sir.
e raised power minus lambda, lambda cube, first of all, this 3 factorial, I can write 3 into 2 factorial equal to e raised power minus lambda, I can take common. I will get 2 lambda squared divided by 2 factorial plus 4 into, 4 lambda. Yes or no? 1 factorial, nothing but 1. So you can see I can cancel out this e raised power minus lambda, e raised power minus lambda. And this 3 will get cancelled out with this 3.
Yes, sir.
Now what is the remaining
Yes.
here? Lambda cube and 2 factorial, nothing but what? 2.
2.
2.
2.
And here 2 will get cancelled out. You will get lambda square plus 4 lambda.
Yeah.
Also, you
Right.
can, if you
Lambda
see,
square plus 4 lambda.
so here I can take lambda common from right hand side. What I will get? Lambda plus
Lambda
4.
plus 4.
1 lambda I can cancel
Lambda.
out. So I got lambda square by 2 equal to lambda plus 4.
Yes, sir.
So
Yes,
what we
sir.
got? Lambda square equal to 2 lambda plus 8.
Right.
8.
So if you will see, this is the quadratic equation. Lambda square minus 2 lambda minus 8 equal to 0.
Yes. Yeah.
Can I solve this? So lambda
Yes, sir.
square minus 4 lambda can I write? Plus 2 lambda minus
2
8 equal
lambda.
to 0.
Yes.
Right? So here lambda I can take common. It will be lambda minus 4 plus 2 times lambda minus 4. Any doubt?
No,
From
sir.
here,
No, sir.
lambda minus 4 into lambda plus 2 equal to 0. So here lambda will be from here lambda minus 4 equal to 0 or lambda plus 2 equal to 0. So here you will get lambda equal to 4 or lambda
Minus
equal
2.
to minus 2. So which value I should
Minus
take?
2.
4.
Plus
I
4.
think 4.
Lambda
Lambda equal to
can't be
4.
negative, sir.
Yeah. So lambda will be 4. So you can see B is the correct answer. Is this clear?
Sir, lambda can't be negative.
Yeah, you
Yes.
tell me whether it should be negative or not.
Well, I'm not
Because
sure.
lambda represent a mean value. So mean value
Right. Right.
not
Now,
The probability function will not be negative, sir.
See here, it will be, this is the case and lambda is always greater than 0. Okay, you can check.
okay. Okay.
You can think, right? Here if you see lambda is less than 0, is this something? This is not making sense, right?
Yeah.
Okay.
Hmm.
So
Yes.
is this clear? Are you getting the idea what kind of questions we are asking during the end-term?
Yes, sir.
Sir, please explain the steps again.
Which steps?
Starting, sir.
So you
Before
should
the
ask
quadratic equation. The
before the
formation of quadratic equation, this is
before the quadratic equation.
sir.
This one or from the beginning you are asking?
From the beginning.
You could inform me at the beginning itself, right? You are not getting. Okay. So this equation is there, right? So what is the probability mass function for your Poisson distribution? X equal probability that x equal to x is nothing but e raised power minus lambda, lambda raised power x divided by x factorial. right? This is the probability mass function. So if you see, this is similar as probability x equal to x. So instead of small x, I have one of the value 3. So if you see, so I can write e raised power minus lambda. So this 3 is this one. And for this probability x equal to 3, I can write e raised power minus lambda into lambda raised power 3 divided by 3 factorial.
Yes, sir.
Similarly, for this part, I can write e raised power minus lambda into lambda square divided by 2 factorial. Okay, you can see this x factorial. So 2 factorial plus 4 into e raised power minus lambda, lambda raised power 1 divided by 1 factorial. So far, so good.
Yes, sir.
Now, we can see e raised power minus lambda, this term is on both sides. So if you'll see from the right hand side, if I will take e raised power minus lambda common, then it will get cancelled out. And this 3 factorial, I can write 3 into 2 factorial or not?
Yes, sir.
And this 3 into 2 factorial, so this 3 will get cancelled out with this 3. And here you got 2 divided by 2 factorial, and 2 factorial nothing but again 2. So this 2 will get cancelled out with this 2 factorial. So what will have here? Lambda square. And 1 factorial nothing but 1. So it will be 4 into lambda. Any doubt till this point?
Clear, sir.
I mean, any doubt? Yes or no?
No, sir.
Right? So what you got here, you can see lambda cube divided by 2, lambda square plus 4 lambda. So if you see, lambda is there on both sides, right? So if I will take lambda common from right hand side, I will get lambda plus 4. Yes or no? And 1 lambda will get cancelled out from here. So what will be the remaining on left hand side? So there were 3 lambda into lambda into lambda. 1 lambda will get cancelled out. So it will be lambda square by 2 equal to lambda plus 4. Now this 2 I can multiply on the right hand side. So it will become lambda square equal to 2 lambda plus 8. Yes or no?
Yes, sir.
Now this lambda square equal to 2 lambda plus 8. If you take one side, that is left hand side, you will get lambda square minus 2 lambda minus 8 equal to 0. Now we have to solve this quadratic equation. So it will be lambda square minus 4 lambda plus 2 lambda minus 8 equal to 0. So for this part, I can take lambda as a common. It will be lambda minus 4 plus here I can take 2 as a common. So it will be lambda minus 4. So I will get lambda minus 4 into lambda plus 2 equal to 0. So I will get two values, lambda minus 4 equal to 0 or lambda plus 2 equal to 0. So from here, lambda equal to 4 or lambda equal to minus 2. So this is not possible. So lambda equal to 4 is the correct answer. Is this clear now?
Yes, sir.
So next question is,
Sir, in Poisson distribution, lambda is our mean.
Yeah, lambda is the mean also, lambda is the variance.
Okay, sir.
Okay. So next question is based on the same information, that Poisson distribution itself. So we have to calculate the value of this part. So if you see, this is just a calculation part. Doesn't, so probability x less than equal to 1, probability x less than equal to 2. Okay. So what I can write here, this means probability x equal to 0 plus probability x equal to 1, right? Divide by probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. And what was the PMF? Probability x equal to x, e raised power minus lambda, lambda raised power x, divided by x factorial, right? And what was the value of lambda? It was 4, right? So what it will be? E raised power minus 4, 4 raised power x divided by x factorial. Yes or no? So we have to just solve this thing. So for probability x equal to 0, it will be e raised power minus 4, 4 raised power 0 divided by 0 factorial plus e raised power minus 4, 4 raised power 1 divided by 1 factorial. Yes or no? This is the numerator part. For the denominator part, it will become e raised power minus 4, 4 raised power 0 divided by 0 factorial plus for this e raised to power minus 4, 4 raised to power 1 divided by 1 factorial plus for this e raised to power minus 4, 4 square divided by 2 factorial. So can you see, can you observe something? So in the numerator part, e raised to power minus 4 I can take common.
Yeah.
And something raised to power 0, 0 factorial nothing but 1. And here only 4 will be there. Divide by. Numerator part is clear to all of you?
Yes, sir.
Yes, sir.
Similarly, from the denominator, e raised to power minus 4 I can take common. So this part is 1. This part is 4. This part is 4 squared divided by 2, which is 16 divided by 2, that is 8. So this will get cancelled out here. 5 divided by 13. So 5 divided by 13, if you will solve this, so 5 divided by...
The 4 square will be 16.
Divided by 2 factorial.
Oh,
divided
okay,
by 2, right?
Yes,
So
sir.
5 divided by 13, nothing but 0.385. So you can see answer is, you have been asked to till 2 decimal places. So actually this is nothing but something 46 will be there. So till 2 decimal places, it will be 0.38. You have to enter the answer. This is clear? Any doubt?
No, sir. No.
Oh, sir.
Sir,
Yes.
would it be wrong to cancel out the common factors of the numerator and denominator?
No, why it is wrong? I have cancelled, right?
No, sir. The previous step.
Where?
This e power minus 4, 4 power 0. Like the common
Addition,
ones.
we can't
So
How
you
can we
mean
cancel?
this whole part you can cancel out this part, whole part?
When you are taking e power
We can't.
minus 4, they are asking how we are.
We can't cancel it.
You can't. Reverse order you can do. Like if it is, let's say, probability, if you can find 1 upon divided by this part, then it will be probability x less or equal to 2 divided by probability x less or equal to 1. Okay. In that case, this whole part will get cancelled out. Are you getting what I'm trying to say?
Yes, sir. Thank you.
Okay. Here you can't cancel.
Sir.
Yes.
I have joined the class late. I wanted one non-academic question.
Okay, we can discuss at the end of the session. That will be beneficial for all. Okay.
So it's just about the formula. I mean, for the last 2 exams, there were the formulas were given. So this time also will there be?
Yeah.
Okay. Thank you.
Yeah. So any doubt? The question is clear to all of you?
Yeah, clear.
Yeah.
Yes, sir.
Can we move next?
Yeah.
Yes.
Yes, sir.
Yes, sir.
So next is called something continuous distributions. Very first is uniform distribution. Okay. So I will give you some idea. So suppose my random variable x follows uniform with parameter a and b. Then PDF is nothing but 1 upon b minus a, and this ax should lie between a and b. Okay, and we know this probability should be greater or equal to 0. Summation of all the probabilities should be equal to 1. This kind of property we have to keep in our mind. And what is the CDF f of x? This means probability capital X less or equal to small x. This is nothing but x minus a divided by b minus a. Yes or no?
Yes, sir.
And what is the expectation of x? A plus b by 2, and variance of x is nothing but b minus a whole squared. Also, see, keep in mind, if you don't know the integration part, no need to worry about. Every question you can do. One more thing I want to specify. What is this part? If I will say a less than x less than b, I can write this as a probability x less or equal to b minus probability x less or equal to a. Yes or no?
Yes, sir.
So you can think like this. Suppose this is your A, this is your B, and X is in between. So I ask for middle part. So to know the middle part, how you can find the middle part? Suppose this is your total green part, X less than or equal to B. Okay. If you will subtract from this green to this red, you can find this middle part or not?
Yes.
Yes.
Yeah, right. This blue. This blue, right?
B minus A.
So to find this blue region, what I have to do? I have to subtract from green minus red, right? the something which I have done. Yes. Yes or no?
Yes, sir.
So this is something you can keep in your mind. So this is nothing but capital F of B, CDF and minus capital F of A. And we know in case of continuous distribution, probability at a single point is 0, right? So if I will ask A less or equal to X less than B, again it will be probability X less or equal to B minus probability X less or equal to A or not?
Yes, sir.
Yes,
What
sir.
about this part? A less or equal to X less or equal to B? Again same.
Yes, sir.
Yes, sir.
Okay. What about this part? A less than X less or equal to B?
Again,
Again,
same.
right?
Yes.
Now,
Yes, sir.
so this is the case. Now this is the question. Okay, I want you guys to try. Okay, so you have 2 minutes. Solve this and let me know whether you are getting the answer.
That's done.
30 is the answer.
Okay, you got the answer, everyone, or you are still
You
trying?
got that.
If you are trying, we can wait.
No, you got the answer already.
So are you able to
Discuss
solve
the
this
answer.
kind of questions, right?
Yeah, yeah.
So you can see it is
You
clearly mentioned, right? Which distribution it's following, right? So what is your X? X follows uniform 20 and 40, right?
Yeah.
Right. So and if you see this part, probability X less or equal to K equal to probability X greater than K. So we have discussed, right? So if we have seen just a few seconds before, if I have probability X less or equal to X, what I can write? X minus A divided by B minus A, right? Where A is lower limit, B is the upper limit of uniform distribution. Yes or no?
Yes, sir.
So here, what is the case? What will be if I will write? Okay, tell me. F of X. So I can write probability capital X less or equal to X. This means X minus A. So A is your 20. Divide by B minus A. So B is 40 minus 20. Clear?
Yes, sir.
So
Yes.
this here, what I can write? Probability X less than or equal to K. One thing you can focus here. So this is greater than sign, right? And we know CDF X less or equal to X. Then what I can write here? Can I write 1 minus probability X less or equal to K?
Yes, sir.
Yes, sir.
So,
Are you getting? So what we'll get from here? Can I write, if you take this as a left hand side, so I will get probability X less or equal to K plus probability X less than or equal to K equal to 1. So we
Yes, sir.
got 2 times probability X less or equal to K equal to 1. Sorry, it will be 1, right?
Yes, sir. Yes, sir.
So what we got from here, so probability x less than or equal to k is nothing but half. So what about this part? So I can write this as a, if you see
K
this
minus
formula,
20 by 20.
correct. So I can write k minus 20 divided by 40 minus 20 equal to half. So what we will get, k minus 20 divided by 20 equal to half. Yes or no? So from here, can I write k minus 20 equal to 20 divided by 2? This you can take right hand side. You will get 10. So from here, it will be k minus 20 equal to 10. So it will be k is equal to 10 plus 20, which is 30. Is this clear?
Yes,
Yeah.
Yes,
Doubt?
sir.
So you are able to relate, right? So you can see, you just need to identify which formula you have to apply. Rest is given to you.
Volume.
Yes or no?
Sir, we can
Troll
solve
is
this
bad
by
at
using integration.
You can solve by using this integration. I'm not using the integration because some of people don't know the integration because they are not.
Volume
Sir,
please.
because I used integration, that's why.
That's okay. That's okay. You can do. That's not bad thing if you are using the integration. I'm not using because some people don't know the integration. So by using this CDF formula only, you
Yes, sir.
can solve the question, right?
Yes, sir.
I have a small insight here. You can
Uh,
actually find it even before.
yeah,
Yeah, when you
correct.
reach P of x less than or equal to k
Hmm.
equal to 1 by 2, the probability of 1 by 2 will happen in uniform distribution in the middle.
Correct. And it's
So
a middle
obviously,
point of
middle
20 and
point of
40.
20 and 40 is
Correct.
actually.
Yeah, that's a good thing actually. So I didn't do. I just solved the question with the means just simply. Okay. So anyway, you are getting the idea, right? What kind of question you can find, right?
Yes, sir.
Were you able to do? Yes or no?
Yes, sir.
Sir, sir,
Yes. Yeah.
sir, I have a doubt.
Huh?
When we have to use formula 1 by b minus a, and when we have to use x minus a by b minus a.
Okay. So if you are just memorizing the formula blindly, then it's going to be like kind of trouble for you. See, this 1 upon b minus a, this is the probability density function. This is PDF. Okay. This is PDF form if you want to do integration and all. So this represents, this capital Fx is for CDF, cumulative distribution function. Okay. So if I will ask what is the probability that x will be less or equal to till some point, then this part, then what from where you will get this formula. You have to integrate this small fx dx from a to x. Okay. And if you will integrate a to x and 1 upon fx, fx is 1 upon b minus a dx, this will give you this formula. Okay. This is just a probability density function. Okay. And this
Okay,
is
sir.
cumulative distribution function. Okay. So I would request you to watch the open session. Okay. That will give you clear idea. Okay.
Thank you, sir.
Yeah. So next question is, what is the probability that a randomly selected steel rod will have a length of more than 25 centimeters? Then what is the meaning of this more than 25 centimeters? What should I write?
X
Greater than or equal to 25.
Greater than
Correct.
25.
And
No,
we have
not equal
information.
to, only greater than.
less than 40.
And we have information x follows in form 20, 40. Right? And we know what is the f of x. It will be x minus a, which is 20, divided by 40 minus 20, b minus a. Yes or no? So this part, can I write 1 minus probability x less than or equal to 25 or not?
Yes.
Why I'm writing? Because I know the CDF formula. I can apply CDF formula here, right? So I can write 1 minus, instead of x, I have 25 minus 20 divided by 40 minus 20. Any doubt till this point?
No, sir.
No, sir.
This will become 1 minus 25 minus
1
20
by
is
4.
5 and 40 minus 20 is 20. So now this will become 1 minus 1 by 4. So 1 minus 1 by 4 is nothing but 3 by 4.
40
So
कहाँ
3
से
by
आया था?
4. 3 by 4
by
is the
4.
answer. Is this clear?
सर 40 कहाँ से आया था?
Okay.
Clear.
40 यहाँ से आया था. Okay, this is A, this is B. Okay, you should be little bit careful. Okay, clear?
Yeah, clear.
Okay.
Sir,
Yes.
if we use integration method, then limit of integration will be 25 to 40.
Yes, because here x is from between 20 to 40, right? And here what you are saying, x should be greater than 25. So you have to integrate 25. What is the upper limit? Till 40.
40. Yes, sir.
Okay.
Yeah.
And you have to integrate 1 upon b minus a, that is 40 minus 20 dx. So if you will solve this, you will get this answer. Okay.
Yes, sir. Yeah. I done with integration.
Yeah, anything is fine. Okay. So next is called exponential distribution. Okay. So what is exponential distribution? I think if you see, I have discussed in when I was discussing the this is from this PDF is from when I was taking the week 12 open session. So when exponential distribution is there, like, so a continuous random variable, suppose whose PDF is given as fx as a lambda into e raised power minus lambda x is greater or equal to 0 for some lambda greater than 0. PDF is this form, otherwise it will take 0. So what is, I took some when it will arise, when exponential distribution arise. Actually, exponential distribution often arises when I'm interested in distribution of the amount of the time until some specific event occurs. Okay, miss, what is the, let's say you are interested in life of a light bulb when it burns out, something like that. I mean, you are interested in distribution of amount of time. So life of light bulb, these kind of things will comes under the exponential distribution. Also, lambda will represent there. Anyone, any idea what lambda will represent? Can you recall from lectures?
Inverse of acceptation.
No, that is formula you are telling me. I'm asking what is the what lambda represent?
Rate parameter.
I don't.
Decay rate.
Correct, rate parameter, right?
Yes.
Okay.
Okay. So actually, your lambda is no, I mean lambda is one of the parameter of your exponential distribution. So it is actually, it will represent the, I mean lambda is nothing but rate parameter. So what I mean by rate, you can treat as a rate parameter, nothing but is the rate at which your events is going to occur. Okay, are you getting? So if you want to specify, you can say lambda is the, like rate at which your events is going to occur. Let's say life of light bulb. You can simply say I told you that what is your x. X represents what? Distribution of amount of time until some specific event occur. Okay, so here x will represent, x is what represent, x is representing the time until the event is going to occur. Okay, so in this kind of scenario, when you are interested in distribution of amount of time until some specific event occur, that will give you, in that scenario, you are going to use the exponential distribution. So if I'm saying x follows exponential distribution with parameter lambda, then what is the PDF? Anyone? F of x? Lambda into e raised power minus lambda x.
Lambda x. Yes.
X should be greater or equal to 0 and lambda is greater than 0. Okay. What is the CDF? Capital
1
F
minus e to the 1 minus e to the power minus lambda x.
Minus lambda a.
1 minus e raised power minus lambda times of
Lambda
small
X.
x.
And if I want to know the expectation, 1 by
Lambda.
variance of x.
Lambda by lambda.
So this kind of information you can keep in your mind. Anyway, this will be
The
given.
volume is dropping.
Sir,
sorry?
Just one. Sir, can you just relate the concept of lambda from the Poisson distribution and also the lambda from this exponential distribution? Actually, I'm getting confused in both these.
See, in case of Poisson distribution, lambda is nothing but you can say it's representing the
But your
average.
voice is very low. I'm sorry to interrupt, but your voice is very low, sir.
No,
for
it's fine.
We are good. Yeah,
No,
for others we are it's good.
not.
Yeah, it's not.
Use earphone.
Yeah, I'm using earphone. That's
No,
not
you're good.
loud.
You're good, sir. For some of
Okay.
them, some of us, you're good.
You are good, sir. The
Sir,
voice is
your voice
unclear.
is good, sir.
Perfect.
Yeah, you are not clear,
Sir,
sir. You
don't
are
go away from mic, sir. That's
No, no, I'm there. It's
No, we are getting clear sound.
now is it fine or
It's
It's
perfect.
fine, sir.
fine, sir. Fine, sir.
fine, right?
It's fine from beginning.
Yes, sir, your voice is good.
Okay, okay, okay. Thanks. Whenever you are facing any like disturbance, do let me know. Okay. Yeah. So I was saying, see here see you can see in case of Poisson distribution. Okay, you can relate what is the expectation of x in case of Poisson distribution, lambda, right? So
Sir, it's lambda.
you can simply treat lambda as the average number of occurrences in that fixed interval of
Right.
time or space. Okay.
Right.
Right. Prajwal asked you this question, right?
Yes, sir.
Okay. So what in when you are using the Poisson distribution, whenever you are interested in number of occurrences of the event in a
Average.
particular interval of time or space. So lambda will represent the average number of occurrences in that fixed interval of time or space. Here, in case of exponential distribution, lambda is nothing but rate parameter, at which rate your events is going to occur. At which rate, let's say life of light bulb will burn out or something like that. Okay.
So rate is just, I think rate is just another way of saying average, isn't it? I mean, we are again saying the same thing.
like speed.
No. In actually, the rate here identifies how fast the curve will reach zero. If you check the lecture, you'll be ma'am will show a image where
Also,
the lambda.
you can see this.
Yeah, this image. Yeah, correct.
Both
Actually,
are
that's why I'm
rates.
saying if you are getting any trouble, please do watch the week 12 open session. So for different values of lambda, you will find this kind of curve. Okay. At which
Yes,
rate
sir.
it is going to close to zero. Okay. So okay, I think I took some examples. If you solve this, you can see here. Question is at a busy coffee shop, customers arrive at on an interval like 10 per hour. Okay, so here you can see what is the rate parameter lambda is 10 customer coming per
10.
hour, right? So here what is the rate per hour I'm talking about, right?
Yes,
10.
sir.
While in case of Poisson, it will be direct average number of occurrences. Okay, you can
Okay,
see
now
another
I got it.
example. Like certain brand of light bulb has an average lifespan of 800 hours. Okay, so here it is given that 1 by lambda as a 800. So lambda will be 1 upon 800. So this is 1 by 800. So out of 800, it's 1 by. So it's a rate thing. Okay.
Yes, sir.
Similarly, you can see this question. Customer service center, they are receiving the phone calls at a rate of 3 calls per hour. So what is the rate here? 3 calls per hour. Are you getting? While in case of Poisson, it's the average number of occurrences of the event. Clear?
Okay, sir. Got it.
So in exponential, it is like the number of occurrences until that specific event occurs.
Correct. That
So
will
if
be
both of the occurrences are same, then the lambda would be same.
both
Like if
occurrences
the
are
bulb switches off in like 8 minutes, and in Poisson we are counting 8 times and it takes 1 minute. So like the occurrences would be same in both. So then lambda would be same or different.
Lambda would be different.
I didn't
Can
get
I
your question.
can I
Actually.
explain?
Yes.
Yeah, please, sir. You can explain.
If you are assuming a coffee shop, say the number of visitors in 1 hour is 10. If you are using a Poisson, we are counting the number of people in 1 hour. That will be lambda will be 10
That's on an average.
on an average. If the same thing, if you are interested, the time taken between two customers. Now you are measuring not the number of customers, you are measuring the time. Yes, exponential distribution comes only to measure the time, not the event. Poisson is used to count the event. So since if you are asking about the time taken between two customers, we will divide the whole thing, right? 1 by 10.
No, but
that will be the time taken between two customers on an average.
So
That
what
is
if it,
in exponential, the lambda comes at the denominator. In Poisson, it comes at the normal. You just try to visualize this as an example. Imagine a Starbucks, 10 customers come in 1 hour. If somebody is asking what will be the probability of 5 customers coming in another half an hour,
Correct, correct.
then
Another
you
case,
use a Poisson.
correct. So
On the
it's
other
a
hand, if somebody says one customer has come, what will be the expected time for the next customer to come? Then you use exponential.
oh, now I got
Yes,
it.
you take 1 by lambda.
that's why. So exponential represents, I told you, right? So it's the rate parameter.
Always remember, exponential is to measure the time between two events. Poisson is to measure the number of occurrences in a given time frame.
So,
it's like a speed versus the distance.
Correct, correct.
Just visualize that.
Thanks for the
But
explanation.
it's-
So here you can see this your x, right? So it's nothing but you can think as it's time until the next event. Okay, next occurrence of the next event. So okay, so that's why we are considering as a rate parameter. And also you can think as a in case of okay, time is something, it comes under the continuous part, yes or no? And in case of Poisson, what we are interested in count of that number of occurrences of the event. Correct?
Yes, sir.
Yes or no? Right? So in case of Poisson, lambda represents average number of occurrences in that fixed interval of time, and where while this in case of exponential, it represents the rate parameter. Okay, and you can see these kind of examples we have taken. So if you see the question is asking what is the probability that time between two successive calls will be more than 20 minutes. So we are interested in the time for the next call. Okay.
Okay.
Now,
Okay.
so next question is here. Like question is, you can think you can see what kind of applications you can do. So question is, suppose the time taken by a delivery service to deliver a package in hours follows exponential distribution with a mean delivery of time 10 hours, right? As we discussed few seconds before. So you can see here we are interested in time, right? Mean delivery time of 10 hours. If someone places an order just before you, then we have to give the answer. So what is the probability that you will have to wait for more than 15 hours for your package to be delivered? So first of all, here x follows, let's say exponential lambda. First of all, what is this part? It's given as mean delivery time of 10 hours, right? That
So
means what?
lambda would be 10. No.
No. That is the
1
mistake.
by 10.
Expectation
Lambda 1
of
by 10.
expectation is given as a 10.
Okay,
Yes,
sir. So
Yeah,
lambda
sir,
would be 1 by 10.
expectation will be our mean always.
Yeah.
Yeah, mean
Yeah.
mean of the year end. So here, what will be the
Okay.
lambda? Lambda is 1 by 10,
0.1.
right?
Okay,
So you
sir.
can see this lambda here. You can relate this lambda represents the rate at which that events occur. Okay. Now, what is the main question? So now be careful these kind of things, right? Sometimes it will give you mean, sometimes maybe variance, and also you have to convert. I mean, you have to find the value of lambda accordingly. So question is,
Right.
what is the probability that you will have to wait for more than 15 hours? So that means what? Probability of x greater than, yes or no?
15. Yes, sir.
Right.
Yes, sir.
So can I write 1 minus probability x less than or equal to 15 because I know the CDF formula?
Yes, sir.
Yes, sir. Yes.
Right. So what we can do, 1 minus, what is the CDF formula? It's a 1 minus probability x less than or equal to x, 1 minus e raised to power minus lambda x.
Yes, sir.
What I can write, 1 minus e raised to power minus lambda. What is the lambda? Okay, let's write lambda into x. What is the x? Is 15. Right? So what I can write, 1 minus 1 plus e raised power minus 15 divided by 10. So 1 will get cancel out. So it will be e raised power minus 1.5. So which is the answer? B is the answer. Is this clear?
Yes, sir.
Yes, sir.
Right?
Clear.
Okay, great.
Yes, sir.
So next part is now you will do this question and let me know which option will be correct. So what is the probability that you will have to wait between 15 hours and 30 hours? Okay, you have one, I think 1 or 2 minutes will be more than it.
Option B.
Option B, sir.
Yes.
B.
Yes.
Okay, I got some vote for option number B. Is this for everyone?
Yes, sir.
Let's.
Yes.
Who got
Option
option
B.
A? Anyone who got option A?
No, sir. I did not got.
No one? Is it?
Option A is the correct answer.
Option A is the correct.
Option A,
Yes,
sir.
yes.
Option A is the correct.
Okay, be careful. If you are able to do this question, this is kind of important. You can say as a bonus point. Okay. So what is the part here you have to focus?
Option B.
So if you see option B is wrong. Question is X will lie between 15 and 30. Yes or no?
Right.
Yes, sir.
So you can see if this is 15 and 30 and we know what is the probability A less than X less than B. I can write probability X less than or equal to B minus probability X less or equal to A, right?
Right.
Yes, sir.
So here I can write probability X less than or equal to 30 minus probability X less than or equal to 15 or not.
Yes, sir.
And for this
Yes, sir.
part, we know in case of exponential distribution, probability X less or equal to X, that is CDF, 1 minus e raised power minus lambda times X.
Yes, sir.
So this part I can write 1 minus e raised power minus lambda times 30. So what is the value of lambda? It's 1 by 10.
1 by 10.
Yeah, 0.1 we can say. So it's a 0.1. Okay, let's write 10 itself. Calculation will be
It's a
easier.
plus minus
So it will
mistake,
be
actually.
30 divided by 10 or not? Minus.
Yes, sir.
1 minus e raised power minus 15 divided by 10. Yes, no?
Yes,
So
sir.
it will be 1 minus e raised power minus 3 minus 1. And this minus will become plus e raised power minus 1.5. This will get cancelled out. So we will get e raised power minus 1.5 minus e raised power minus 3. So option A is the correct,
A is
not
the right
B.
answer.
Okay, be
Calculation
careful
has been mistake.
while
Actually,
you
there
are
was
doing.
plus minus error.
Be careful while you are doing
सर
this kind
स्क्रीन
of.
आपका नहीं दिख रहा.
Yeah.
Yeah, I will explain. Okay. So be careful while you are doing this kind of questions. So
Yes.
yeah, screen is visible, right?
Yes, sir.
Yes,
Screen is
sir.
visible.
Yes, sir. Sir.
All right, great. So let's move to the next question. Okay. Yeah, so in case also I mentioned in while I will taking the week 12 open session. So there is, there will be there. So it's a very specific thing. There is only one question from normal distribution of 2 marks. Okay. Which you can do by watching the lecture video is more than enough to do the normal questions from normal distributions. Okay. Let me just give you some idea. So if suppose X follow normal, okay, with mean mu, variance sigma square, okay, and we have seen if this is the case, we saw, if what is the case if X will lie between mu minus sigma and mu plus sigma, how much probability? 0.68 something, right?
Yes, sir.
Yes.
If it will lie between 2 standard deviation, then
0.95.
0.95
0.95.
0.95.
and 3 sigma.
0.997.
0.997.
Okay, and we have also seen how to convert in standard normal. So x minus mu divided by sigma, where mu is expectation of x, sigma is standard deviation. This will follow normal 0, 1. We saw this is symmetric, right, curve. Okay, bell shaped curve. So due to that,
Sir, what is
can I say
represent Z?
probability z greater than 0, probability z less or equal to 0. This is half, because so this is something bell shaped curve you will get. So this peak will be at mean equal to 0. So this will represent the 50% area. This will represent the 50% area. So z is nothing but it's called standard normal variable. How we can get this z? Nothing but x, your normal random variable, minus mean expectation that, and divide by standard deviation. Okay. Yes or no? And suppose you have any
Yes, sir.
point here, let's say minus a, and here is there is only any point a. So probability z less or equal to minus a will be same as probability z greater than or equal to a. Yes or no?
Yeah.
Because of
Yes,
symmetricity, right? These kind of things we
Yes,
have
sir.
seen.
Yes.
Okay. Now let's move to the question. I told you, right? This is the more than enough to do the questions. So this is the one of the question which we have asked the last term itself. By using this information, choose the correct option. Which
B
options
is
will
the
be correct?
Option
Sorry?
B.
Option?
B.
Option B.
B
Sir,
and
option
D.
D.
Option D.
Option D.
Only option D or B and D?
Option D. B and D.
B
Yes,
and
sir.
D.
B and D, right?
Yes.
Why not
Yeah.
A? What is the wrong with A?
It is equal as it is symmetricity.
Equal.
A is equals.
Correct. It should be equal, right?
Yes.
Because this is bell
Yes,
shaped
sir.
curve, right? And peak is always at mu. So this should be equal part. So that's why it's wrong. And here I can say this is the correct one, right? So this part, x less or equal to mu, x greater than mu will be 0.5. This is incorrect, and this is correct because x minus mu divided by sigma is the standard normal variable, and then z will follow the normal 0, 1. Okay, this kind of basic. Okay, what if I will write? Tell me if I will write. Let's say 5 less than x less than 10. Then what you will write? Can I write probability x less than or equal to 10 minus
10
probability
minus probability.
x less or equal to 5?
Yes.
Yes or no?
Yes, sir.
After
Yes.
this, can I convert in standard normal variable? So what I can write? X minus mu divided by sigma less or equal to 10 minus mu divided by sigma. Yes or no? Both sides.
Yes, sir.
Suppose I want to convert in standard normal form. Here it will become x minus mu by sigma less or equal to 5 minus mu by sigma.
Yes,
Right?
sir.
So what is this? Now this I can write z less or equal to 10 minus mu by sigma minus p z less or equal to 5 minus mu by sigma. Yes or no? So for different
Yes,
value
sir.
of mu and sigma, you will get some values here. Okay. Clear?
Sir, can you explain option B, sir? Once.
Yeah. So
I
option B is nothing but, so normal. If you see the normal curve, right? I have the PDF actually. Curve of normal. It is
Sir,
the
basically equality sign is why on holding left side, sir.
no, you can do either side. That's not a problem.
Oh, okay.
So because this, see, if I will say in case of continuous probability at a single point, right? Any single point, it is always 0. Okay. So if I'm saying z lesser, let's say probability x lesser equal to mu, this is same as probability x greater than mu. If I will say
Yes, sir.
probability x less than mu, this is same as probability x greater than or equal to. Okay. So where
So,
is
sir,
my, yeah.
graph of normal distribution never changes. It is fixed.
Yeah, how graph will change of a particular distribution? So for different values of mu and sigma, you will get different things. But main thing is
Shape of graph is fixed.
shape will be same. If you see, peak will always be at mu. Okay, at mean. Okay. Let me show you that one thing. Give me a minute. We have the thing. So shape of the normal distribution will always be at mu. Okay. I mean peak will be always at mu of u. Okay. Now you can see here. So peak is always at mu. Okay. Mu is supposed to. You can see for different values of sigma. Okay. When sigma is less, so 0.5 you can find this curve, right? Less variability. Okay. Less spreadness in the curve. If sigma is equal to 1, you can find this curve. There is a bit more spread. If sigma is equal to 2, you will find this last curve when there is more spread as compared to the sigma is equal to 0.1, 0.5 and 0.1. Okay. And if you will observe, peak is always at mu. Fine, right? Similarly, here you can see for different values of mu, you can find, and for a fixed value of sigma, you can find this curve. So here you can see peak as -2, peak is at 0, peak is at 2. Fine. And
Yes,
this
from
is this is
converting.
this is symmetric curve actually. So that's why this probability x less or equal to mu and probability x greater than mu, this is same, which is half. You will add, here you can see, if you'll add, this part will give you total probability if you'll add both part. Okay.
So the from converting standard to normal standard distribution. So that part is little bit confused, and give some example and clear some sum so that we'll have a good idea about it.
So okay, standard rule is how to convert in standard normal variable. Let's say, for example, let me write itself. Suppose I'm saying, let's say I'm saying x follows normal with mean, let's say 10, and variance is 4. So this is variance. Okay. Suppose this is mu. Okay. How I can convert in standard normal variable? So rule is, so x minus expectation of x divided by standard deviation of x. Okay. So what is x? What is the expectation of x here? 10. Standard deviation of x is 2. This will follow normal 0, 1. Means in this part, for this part, mean will be 0, variance will be 1. Do you want to verify?
Yeah.
Okay. I think. Okay. Maybe we did in the last session.
Sir, here we took sigma squared, and there in the previous question we took just sigma in the denominator.
No.
It is basically representation in different book.
No, see. That is not in denominator. It will always be sigma. That is the standard deviation. Sigma square represents the variance. Let me find some fresh page where I can. Okay. Anyway, I have. Yeah. So let me write. See here. Suppose I'm saying. So suppose x follows normal. I took 10, 4. Right. So this is mu. This is sigma square. I'm saying. So how I can convert z equal to x minus expectation of x divided by standard deviation of x. So it will be x minus 10 divided by 2. Okay. So what is the standard deviation? Sigma square is variance. Then sigma will be standard deviation square root. Okay. This will follow normal 0, 1. Okay. Let me do in general. Suppose I'm saying x follow normal with mean mu variance sigma square. Then z will be x minus mu divided by sigma. Yes or no? Now let's cross verify this 0 and 1. So expectation of z will be what? Expectation of x minus mu divided by sigma. And 1 by sigma is what? This is a constant. I can write 1 by sigma expectation of x minus mu or not. We have seen, right? Expectation of ax is nothing but a times expectation of x.
Yeah.
All right. So this will become 1 by sigma, and numerator part will be expectation of x minus expectation of mu will again give you mu. We have seen expectation of a constant is nothing but that constant.
Yes.
All right. Right. So what it will be now, 1 by sigma expectation of x is what? Mu. So mu minus mu, it will be 0.
Okay.
Okay. Now, and what is, let's see the variance. So variance of z, variance of x minus mu divided by sigma. it will become 1 by sigma square variance of x minus mu, right?
Yes.
So 1 by sigma square variance of x minus mu, we know there will not be any effect by adding or subtracting a constant. It will become variance of x again. What is the variance of x? Sigma square by sigma square will be 1. So for standard normal variable, mean will be 0 and variance will be 1.
Correct.
Clear? Correct?
Okay. So can you give me any example of sum and just from converting from year to year?
Yeah. It's okay. So thing is that if you see the PDF of normal distribution, right? So it's a very difficult to do the integration actually. Okay. So in case of normal distribution, that is the one of the very important, or you can say key thing when we are converting in standard normal table, because we have been given Z table. Okay.
Yeah.
FZ table actually. From that table, we can find the values. Let me show you. Just give me a minute. I think we have discussed a lot about this in week 12 open session. So whenever you have been given any question, right, you can simply convert your random variable in a standard normal variable, and then you can find the value from the G table. Okay. Suppose I will tell you how you can see the value. Suppose you got probability after converting, you got probability Z less or equal to 0.1. Okay. Then 0.1 value will be this part 0.1, and other places you can see from here. So it will be 0.398. Suppose you got probability Z less or equal to 0.11. So 0.1 from here and 0.11. So this one you can see from here. So value will be 0.5438. So final answer will be 0.5438. Let me give you, let me show you the question. Suppose this part. Suppose question is probability Z less or equal to 2.2. So you can find the value of 2.2, which is 0.9861. Are you getting how to see from tables?
Yeah.
Also, just keep in mind this table will give you FZ. I mean, always it will give you the value for probability Z less or equal to Z. Okay. So whenever you have greater than sign, you can convert 1 minus probability Z less than 1 part. Then you can substitute the value. Let me go take the application question, which there is application.
So if there is x in the question, so is substitute in that x minus mu by
sigma.
Sigma. So that will
now
be
you
getting
you
some.
can see
That is a f.
Question. Suppose IQ examination scores of students of a particular school are normally distributed with mean 140 and standard deviation 10. Okay, this means mu is 140, sigma is 10. Question is, what is the probability that randomly selected chosen student has a score of greater than 130, right? Another way, what you can do, you have to integrate 130 to infinity, that 1 upon root 2 pi sigma, that right? That we are not doing.
Take time.
Yeah. So what you can do, we can convert this as a standard normal variable, because we have this G table. Now, how can I can convert x greater than 130? I can subtract x minus what is the mean 140 divided by sigma is 10, greater than 130 minus 140 divided by 10.
Yeah.
Are you getting? On both sides we have to do, right? If we are doing, let's say x greater than 3, if I'm multiplying 2, so 2x greater than 2 into 3, that is 6, right? You have to perform on both sides. So what it will be? 130 minus 140, that is minus 10, divided by 10, which is z greater than minus 1.
Yes.
Z greater than minus 1, value will be 0.84. Got it?
Okay. So greater than, so we have to get less than and 1 minus that.
We have to get, basically you can write 1 minus probability Z less than or equal to minus 1, and then probability Z less than equal to minus 1, what it will be?
It's a greater than 1.
Greater than 1, right? And 1 minus Z greater than 1, this is probability Z less or equal to.
Understood. Thank you.
Okay. So you can see the question something like this. Okay. So let me erase this part. Okay. So next, anyone can explain me when you will be using hypergeometric distribution?
When there is without replacement case.
Okay. Along with without replacement, is there any other condition?
Infinite. Quality of sector is not same, is not
Like the
constant.
success probability is not same.
Independent, not
Correct.
independent.
Yes.
It's a kind of opposite to binomial, right? In
I agree, sir.
binomial, trials were independent and success probability were same for each trials, right? In case of hypergeometric, you will get dependency, and due to dependency and without replacement, okay, your success probability is not same for
Same.
each trial, right? Okay, so let me write the situation. So if I'm saying X follows hypergeometric distribution, so when it occurs, let's say you have total capital N balls. Okay. So whenever your population has been divided into two groups, so suppose out of M and N balls, M are of red color. Okay. So N minus M, let's say, will be having blue color, for example. Okay. There, this capital N has been divided into two parts. Now from here, I'm going to select small N balls, okay, randomly without replacement. Okay. Suppose X represents number of red balls drawn in the selected sample. Okay. So here you can relate. So X will be defined for red. So this you can represent small m, just to keep in mind. So what will the probability that X will be I? Okay, means I will be red balls. First of all, what is the total case?
I mean,
in how many ways you can choose N balls? NCN,
oh yes, sir.
right? And here you are interested, what is the favorable case? I means I ball are red color. So that means MCI,
Right.
remaining ball will be from blue. It will be small n minus I.
Right.
Yeah. So this is something
Sir,
PMF
what
of
M denotes?
M
What M?
denotes this another one kind of so here total population has been divided into two parts. One is red, one is blue. You can say anything. Let's say pass, fail, something like that. And accordingly, your M you can define where when you are interested in success. Let's say here I'm interested in number of red balls, right? So I would be interested for probabilities of red balls at each trial. Okay.
So M will be the number of red balls here.
Yes, yes, yes. And expectation of X in case of hypergeometric is nothing but small n is to small m divided by capital N. Okay, we have seen these things. Okay. So clear, right? Some rough ideas. Okay. Let's see the question. Can we move to the question part?
Oh yes, sir.
Yes, sir.
Okay. So this is the question. Can you try if you want? So there are two ways for doing this question. Sorry.
Sir, voice is audible for all.
Sir is not saying anything.
Okay, thank you.
So anyone got the answer or you didn't try? Yes, no?
Option D, sir.
Option D.
B.
Okay. Anybody else who tried?
B.
B. Okay. B, D. Anybody else? So first of all, what kind of distribution you can apply here?
Hypergeometric.
Hypergeometric. Why?
The selection is changing. I mean, every time.
Probability changing also. Yeah.
Yeah.
Okay.
It's a without replacement
Small
case.
n is n. Yeah.
Man, we cannot take him back, right?
Okay. Also, we can see, right? So here success probability will get changed at every trial. Also, you can see what is the total number of persons?
11.
11, right?
11.
Out of 11, 6 are men and 5 are
Female.
So you can see your X is defined as number of
people,
male, right? Which in the interview pool, and Y is the number of female. Okay. So if I'm interested, okay, here you can see there is two way. First one is I can directly apply this formula, n into m divided by capital N. But thing is that we have
It
to
would
identify
be-
what is small n, what is small m. So here small n is 5, right? Sorry, 2.
2.
Right? But what is the m if I'm considering this x? So in this case, m will be 6.
5. Yes, sir. 6.
6 because I'm interested in men, right? So what will be the expectation of x? N into m divided by capital N. So it will be 2 into 6 divided by 11.
11.
So that is 12 by 11. If I'm interested in number of female, then what will be my small m?
10 by
11.
6.
5, right? So n into m divided by n, it will be 2 into 5 divided by 11, which is 10 by 11. So expectation of x plus y, I can write expectation of x plus expectation of y, which is 12 by 11 plus 10 by 11, which is 22 by 11. That is nothing but 2, right? So we can see this will give you 2. Yes or no?
Yes.
Yes,
Now
sir.
this is the one way. Suppose you are not able to identify this, x, m, n, and all. You can do without using the expectation of the expectation formula of hypergeometric. You can think what x represents number of men in interview pool, right? So what is the possible values your x can take? 0,
0, 1, 2.
Yes or no? If x is taking 0 and 1, 2, then what will be the probabilities, right? We'll go the formal, I mean, as usual approach of expectation. So if I want to choose, what is the probability x equal to 0?
6 is 0 divided by 11 C2.
Only 6 is 0.
Into 5C.
Correct?
5C2.
So there are 6 men
Correct.
and
Into
5
5C2.
women.
Yeah.
Right. So 5 into 5C2. Okay,
Yeah.
because in total we have to choose 2 people.
Plus.
What about 1? 1 man, that means
61
remaining
and
will be
51.
women. 11 C2. And what
Yeah.
about this? All are
6 C2 0.
11
Correct?
C2. Yeah.
Yes.
So 11 C2, it will be 11 factorial divided by 2 factorial into 9 factorial. So 9 will get cancelled out. 2 into 5, 45. Okay.
55.
Sorry, 55. Sorry, 55. So this will become 6 0 is nothing but 1. 5 C2 is 10. So 10 divided by 55. Actually 11 C2 if you divide 55. What about this part? 30 divided by?
Yeah.
And this 62 is nothing but 15 divided by 55, right? So what is the expectation of x? Expectation of is nothing but summation of x into all the probabilities, right? So 0 into this probability plus 1 into 30 divided by 25 plus 2 into 15 divided by 55. So this will be 0, 30 plus 30. This is 60 divided by 50.
55.
Yes or no?
Yeah.
if y is the number of women, again it will be 0, 1 and 2. What will the probability y equal to y?
5C0, 6C1.
Yeah, so 5C0 into 6C2 divided by 11C2. In total, we have to choose 2 people. Similarly, 1 means while represents the 1 women. That means 5C1 and 6C1 divided by 11C2. Any doubt, anybody here?
No.
And 2 means all are women. Okay. So now if you will solve this, so this expectation of y, 0 into this probability will give you 0 plus 1 into this probability will give you 5 into 6, that is 30 divided by 55 plus 2 into 5C2 is nothing but 10 divided by 55. This is 50 divided by 55. And we are interested in expectation of x plus y, which is nothing but expectation of x plus expectation of y, which is 60 divided by 55 plus 50 divided by 55, which is 110 divided by 55, which is again 2. Is this clear? This is the correct. This is clear?
Clear, clear.
Okay. So if you
Yes,
know
sir.
the, if you are able to identify and you can do within a minute. If you not, even you can solve the questions without using this one. All right.
I got the answer, but searching my answer is not there.
Can I give another?
22 by 11.
Yeah, please go ahead. Go ahead.
The whole experiment, we are selecting two people.
Correct.
Either that can be a male or female.
Yes.
So if x plus y is going to be the total, I mean, if you take the average, we are selecting 2 people, it will be always 2.
Okay, yeah. Smartest approach. Yeah, all right. Yeah, correct. So everyone got this?
Yes, sir.
Yes.
Okay. Now, so next question, since I have discussed the questions related to exponential, I want everyone to do, because this kind of questions is already we have given some previous term. So I would like to hear from, I would like to, you should try. You, or else you can simply you can explain me what is the approach.
Sir, I couldn't understand the explanation given by Bhaskaran, sir.
Okay. So Bhaskaran, sir, could you please?
Different explanation.
Yeah, what I'm saying is the experiment is that we are selecting out of 11 people, 2 people.
Yes, sir.
Classifying X as the male and Y as the female. But the result is, what we are asked is X plus Y. We are selecting 2. It could be 0, 1, 1, 1, 1, 0,
Yeah.
2, 0, right?
Right.
These are the possibilities. So the expected value, on average, we are selecting 2 people. So that is the expected value. That is why we are getting the answer 2.
Oh, okay. Okay. Now got it. Thank you, sir.
There is a box with 2 different marbles. You pick up 2 marbles, classify one as a red and the other is probably blue. That is X and Y. But the result asked is, how much? What is the average of X plus Y? It will be always 2.
Right. Right.
That's a logical way of looking at this problem. But the purpose of we trying to solve is to understand how we can
relate the distribution.
This probability functions, what we are discussing. In real life, those functions will be useful in complex situations. This is just a fundamental. You have got to clearly understand how we can use this to arrive at the total.
Right, sir. Right. Thank you.
So you are saying the n value of 0, 1, 2, the 2 value, the n value is saying?
No, what I am saying is we are picking up 2 people, right?
Yeah, 6 from 6 and 5.
So X plus Y will always be 2.
Yes.
So the expected value of X plus Y will be 2. There is no variation.
Okay, if there is 3 means that then it will be 3.
Yes.
Okay. Thank you.
Because the problem was very simple, x plus y. If it is only x, then this logic will not work. Then you have got to worry about what will be the probability constitution in the box.
Yeah, so you have to find
And if there are
the
3 colors in the example that he gave, it will still not work, right? Because then x plus y plus z may not be.
That's different.
Yeah.
Here there are only 2
Correct.
possibilities, and both are we are giving an x and y. Sum of x plus y always will be 2.
Correct.
Yeah,
correct.
okay, because
Thank
we
you,
are
sir.
dividing our whole population in only 2 parts, right? And after that we are interested only in x plus y, not
Correct.
okay. So that's what actually we are doing like this. So just to
This is the exercise to understand the
correct how
distribution.
to
I'm
relate.
not questioning that. The
No,
purpose
no,
of
no,
the
no, no.
question was
I'm
that.
not.
No,
I'm
but
not saying.
if you understand the problem more clearly, then there will be a lot of easy way out like this.
Correct,
Or
correct.
at least
So
we will be able to apply, what to apply, what not to apply.
correct. So whenever you will see these kind of questions in real life, then you can do. I mean, you can understand the logic behind this. As Bhaskaran has explained, and within a minute you can tell the answer, and you can get the what is the back end algorithm behind it, rather than solving this kind of.
Such an insight will be very important for a statistic.
Yes, correct,
Yes,
correct.
of
So
course. When it comes
statistics
to
is
this,
all about insight actually.
people have got to go through this and then be clear what we are doing, why we are doing, rather than just
Yeah,
formula and
applying and get the answers. Yes.
That's what we are doing. Lots of
yeah,
problems.
I know. And you're doing
So that you should get idea where to apply, where not to apply, in which scenario you have to apply these things, in which scenario you have you not you
In
have.
fact, I come across many questions where people are asking why continuous distribution, that if it is exact, why it is 0.
Okay, okay, okay.
So that they need to probably be clear.
Yeah, okay. Is what not clear?
No, many times, many students, not only in this session, earlier sessions, many times. I mean, I keep students asking about why is it 0. They don't know, because somebody told it is 0. They probably accept it as a 0.
Okay, and it's easy to memorize, so they it's easy to memorize, so they memorized it. Exactly.
Yeah, I just put a comment on that possibility was people.
Okay, okay, I will look. Actually, that is also you can find from the graph, or if you are interested in the integration part actually. Okay. Okay, so let's come to this question. So you can see here what is the scenario. We are interested in waiting time, which is in minutes, between 2 successive phone calls. It says exponential distribution with mean 4, right? So with mean 4, that means what? What is given to us? If x follows exponential lambda, so expectation of x is given to us, right?
4.
4.
So 1 by lambda is given to us as a 4, right? Not lambda.
Yes, sir.
Okay.
So lambda would be 4.
Lambda would be 4, or lambda would
Lambda
be
would be
1
1
by
by
4?
4. Lambda would be 1 by 4.
Okay, 1 by 4.
Right. And what is the question? What is the probability that you have to wait for more than 15 minutes? Right? Between 2 successive phone calls, right? So more than 15 minutes, what? I can write 1 minus probability x less or equal to 15.
But sir, lambda was representing 4, right? Sorry, mean was lambda was representing mean in exponential distribution, right?
That was for Poisson
Lambda
distribution.
is time.
Yeah, that is
Okay.
Poisson.
That is Poisson.
Sequence of time.
Okay. So this part I can write 1 minus probability that x less or equal to 15. And we know what is this? This represents the CDF, right?
Of exponential distribution.
Correct. So what is the CDF? 1 minus e raised to minus lambda times of x. Yes or no? This is CDF in case of exponential distribution. So I can write 1 minus for this e raised to minus lambda is 1 by 4. And what is the x? X is 15. Right? So 15 divided by 4. This step is clear to all of you? Yes, no?
Yes,
Ah,
sir.
yes.
Right. So what you will get? 1 minus 1 plus e raised to minus 3.75. 15 divided by 4
Yeah.
actually.
Yes.
Right. So what we got, e raised power minus 3.75. So you have to find the value of e raised power minus 3.75.
That's answer.
So it will be
0.024.
exponential of minus 3.75. So 0.024. Okay, because it has been asked till 3 decimal place, so it will be 0.02. Clear? You can see the level of the questions. Now tell me, that probability at a single point. Now, if you are able to understand this kind of question, this is important. Okay, if you are able to understand,
Zero.
then you will get,
Zero,
this
sir.
is something you can say hint for your end-term exam.
It will be
So what is
zero
the question
because
saying?
it will
Question
be
saying, correct. Question saying, internet service provider advertises a download speed between 50 Mbps and 100 Mbps for its basic plan. Suppose X represents that speed, so it will uniform 50 Mbps and 100 Mbps. Yes or no? This is the information. Question: what is the probability that a user on this plan will experience a download speed of exactly 60 Mbps? That is the
Zero.
question.
0.
0. Right? You'll get
Yes, sir.
some, if you'll talk about marks, you'll get some marks within a second. Okay, so this is the continuous distribution. I think Bhaskaran has also explained how to, what is the agenda behind this. We can think like this also. Suppose you have PDF f of x. You
even
talk
if
about
we integrated, it will be like 60.
Correct.
Integration 60, so it will be
Suppose,
0.
this is 1 upon b minus a. So what is this probability? X equal to 60 means I have to integrate from 60 to 60, right?
60,
Yes, sir.
fx dx, right? If you'll do, so what is this fx dx? 60 to 60, 1 upon b minus a
B
dx.
minus A.
1 upon b minus a, I can take outside. It will be x 60 to 60, upper limit minus lower limit. It will be 0, right?
Yeah.
Divided by b minus a. Okay. So probability at a single point in continuous distribution is 0. You can think like this also. Suppose I have CDF graph. This is, I am getting CDF graph is like this. Suppose this is 1, this is 0. So in case of discrete, we saw, if I'm interested in probability at a single point, then how I can find? I can find probability at this jump, right? Yes or no?
That is discrete.
That is discrete. But in case of continuous, can you find probability at a single point? Is there any jump?
No. That is continuous.
There is no jump. You can think there is no jump. That's why this probability at a single point is 0 in case of continuous distribution. All right?
Yeah.
Yes, sir.
Now, next question. I'm going to give you some 2 minutes and solve this, because this kind of question is very, very important. You should think what will be the, how to, or else if you do not want to try, you can tell me the approach. I will write.
Sir, we can write probability x is greater than equal to 80 by probability x greater than equal to 70. We can use conditional probability.
Yeah, conditional probability. So this was the same, like similar question was discussed yesterday, I guess.
Yesterday,
So,
yes.
okay.
Ma'am was discussing.
What is the question?
Today she discussed.
So probability, what is the question? So we have to find the probability that user on this plan experiences a download speed of at least 80 Mbps. So what is the meaning of at least? Greater than or equal to 80.
80.
Given that
Intersection.
user has experienced download speed of at least 70.
Oh yes,
right?
sir.
And we know what is the probability of A given B? Probability
A
of A
intersection.
intersection B divided by probability of
B.
So what I can write from here, probability of x greater than or equal to 80 and greater than or equal to 70 divided by probability x greater than or equal to 70. Yes or no?
Yes.
If
We
you
can
think
ignore
this as
the
a,
greater than equal to 70.
I
Because
will come to
obviously
In the
if
numerator
more than
part.
80, then
suppose this is 70 and this is 80, right? And I'm interested in probability x suppose this is greater than 80, this part will be there, right? And probability x greater than 70 will be this part, right? So what is the common?
Greater than 80.
This is the common, right? So numerator part will be x greater than or equal to 80 divided by probability x greater than or equal to 70 or not.
Yeah.
Now to apply the CDF formula, what I should write? 1 minus probability x less than or equal to 80 divided by 1 minus probability x less than or equal to 70. Yes,
Yes,
no?
sir. Yes,
And
sir.
what is the CDF formula in case of uniform distribution? It's x minus a divided by
B minus.
And what is a and b here? It's
50
50 and 100, right?
and 100.
So what I can write numerator part 1 minus, so it will be 80 minus 50 divided by 100
50.
minus 50. Denominator part will be 1 minus 70 minus 50 divided by 100 minus 50, correct?
Yeah.
It will be 1 minus 30 by 50, 1 minus 3 by 5, right? And 1 minus 2 by 5. 20 divided by 50, yeah. So this will be 5 minus 3 divided by 5, 2 by 5, and this will become 3 by 5. 5 will get cancelled out, so 2 by 3 is the answer. So we can see 2 by 3, which is B, is the correct. Is this clear?
Yes, dear.
Yes, sir.
Yes, sir.
Now, what about this question? Yeah, someone is asking. Prajwal, can you mute yourself?
Actually, in the previous question, there's there's one more way to actually think about this. Can I share?
The graph method.
Yeah, please go ahead.
No, not the graph. See, actually, initially the distribution is between 50 to 100, isn't it?
100. Yeah.
Now, since they're saying it's at least 70, you can change that distribution to 70 to 100.
That's what I'm saying.
And-
Graph it is.
Yeah.
Yeah,
From
70 to
70
100
and your 80, 80 divided
80.
by
Simply you apply
80 to
80 and
100
you get
divided
the
by
answer.
70 minus. Yeah, that's one.
Correct. So actually, you can think this is suppose this is 50 and this is 100, right? So suppose probability will be 1 by 50. Suppose this is 1 by 50 will be same for this, right? So
No.
question
I'm
is,
not talking. I'm not saying like this. See,
yeah, I will.
the lower limit is 50, isn't it? Initially in the sum.
Yeah.
But
So
they're
okay.
saying now the lower limit is 70. Just change the distribution to u of 70, 100. That's all.
Yeah, that's what I'm saying. So now this will become 70.
Correct.
And suppose
And
somewhat
you
is
have
the
to find
80,
the
right?
80. Correct.
So now we are interested in this part, right?
Correct.
So we
That
can do,
part,
that's
what
not
is
a
the 80?
problem. Yeah. So I'm doing like this just to
No. Just I said the insight.
that's okay.
That's all.
Yeah. Okay. So this is actually you can think. So now you can think your new sample space is you are talking about after.
Yeah, the answer would be 80 minus 70 by 100 minus 70. That you have to minus from 1. And you'll get the same answer.
Okay. What about this part? This question number 11. This is, I think, again, can you tell me what should I write? The time it takes for a computer system to reboot after a crash is follow exponential distribution with a mean time of 0.5 hours. That means expectation of x is given to us 1 by lambda as a 0.5, right? Not lambda. So lambda will be 1 by 0.5, which is 2. Question is, what is the probability the system will be back online within 1 hour of the crash? That means what? X greater than equal to 1, right?
Within 1 hour.
Less than.
Sir, it will be less than.
Less than equal
Correct.
to.
So now I can apply 1 minus e raised power minus lambda into x. CDF formula. So x is 1. It will be 1 minus e raised power minus lambda. It will be 1 minus e raised power minus 2, which is answer. So you can see the questions it's like if you know the concept, if you know the basic formula, you can do within a minute. Okay. So these all questions I have taken from the some previous terms. Okay. Very last question. Just solve this or let me know whether you are getting answer D or not. Be honest. If you're not, I will solve.
Sir, all formulas will be provided in the exam. These all formulas.
Yes, bro, it will be provided.
Okay.
Yes, sir. We can solve it like we get that px is more than 1 is equal to 1 minus px is less than 1.
Okay, this is
Oh,
the
yes,
part,
sir, D option.
right? So what we, if we want to find the value of variance of x, that means what?
1
We have
by
to
lambda
calculate
square.
1 by lambda square, right? So first of all, I have to calculate the lambda, right? From this information. So what is the, this is, here I can apply the CDF. Yes or no?
Yes, sir.
Yes.
Right? Basically what I can do, probability x lesser equal to 1 equal to,
1
this part I can
minus
write 1
probability
minus
less
probability
than.
x lesser equal to 2, sorry 1, right? And if you take this left hand side, what you will get? Probability x lesser equal to 1 plus probability x lesser equal to 1 equal to 1. It's 2 times probability x lesser equal to 1 equal to 1. What you will get from here? Probability x lesser equal to 1 equal to half, right?
Half.
Now, what is this? I can write 1 minus e raised power minus lambda times of x, right? X is nothing but 1 here. This is 1. It will be half, right? What will be the value of e raised power minus lambda here? Again, 1 minus half, which is half. So far, so good?
Log
Or you
both
can say,
sides.
yeah. So now what we can do, okay, first of all, can you tell me this e raised power minus lambda equal to half? Can I write this e raised power minus lambda as 1
1
upon e
by.
raised power
Yes.
lambda?
Yes.
This step is okay to all of you? Now, if this is the case, can I write e raised power lambda as a 2?
Yes.
Now, this is the case, take log on both sides. It will be ln e raised power lambda, ln 2. So this will become, and we know ln e raised power x is nothing but x. So ln is
X.
with base AE. So this will become lambda equal to ln 2. So this is value of lambda. And we know what is the variance. Variance of x is nothing but 1 by lambda square. So it will be 1 upon ln 2 whole square. So this is the variance formula. Clear? Any doubt in this question?
No, sir.
Okay, so everyone, okay, this was the end. Everyone got the idea what kind of questions and how, like, you can apply the formulas
sir.
and all.
Yes, sir.
Yes,
Right?
sir.
Was it helpful for everyone? Like you got the
Yes, of
idea?
course,
Yes,
it's
sir.
helpful.
Yeah.
Yes, sir.
Yes, sir.
Sir, can we get the PDF of this anytime on this
Yeah.
questions we
Yeah,
discussed
sure,
about?
sure. So I will share in the chat box right now.
Okay, sir.
Okay. Also, I will share with the support team. They will upload on the portal under supplementary content. Okay. So for now, I'm going to share in the Zoom chat that will, you can access from there.
And this session will also be available on YouTube, right?
Yeah, it's already available.
Okay.
So it's you can check your
And sir,
calendar. Yeah.
so you said the normal distribution. So one questions are like 2 mark question, 1 or 2.
Yeah. There is only one question from normal distribution. Accordingly, you
Yes,
can
sir.
prepare from the normal distribution. So
I'm
actually,
not.
the thing which we have discussed in today's session, or you can find from week 12 open session, that is more than enough to solve the questions from normal distribution.
Okay, sir. What I'm asking is, I'm not watch any lectures of normal distribution, right? I'm just
Okay. So
completed the exponential.
uh,
That's what I'm trying to ask,
no,
sir.
so you can, if you got some idea from today's session, that is more than enough. Or else I would recommend to watch at least lecture. If you're not able to solve the question, that's fine, not a problem. You can watch at least lecture so that you will get the idea from the
Idea
it's a,
about that
it's a
content
very
also.
it's a very basic question, right? The question I have discussed that normal distribution, similar questions from normal. Okay, so I've shared the PDF in Zoom chat. Everyone is able to access. Can you check?
Yes.
That is not the answer. Whatever you written is not available. It's a plain.
No, it's not a plain. Just wait for a few seconds. Can you check? Just open it and wait for a few seconds.
Sir, we will.
It's coming.
Sir,
It's coming, right?
Yeah.
Okay. Okay. Oh, all right. Okay. Then I hope you got the idea.
Sir,
Yes.
hello.
Yes, please. Hello.
Yes, sir. Hello.
Yeah, I think Pranod was saying something. Maybe.
sir, we will have mock solving class also.
Yeah. Friday 8 to 10 we have. Please check your
Yes, sir.
calendar, right? Everything is mentioned there, right?
So will you take the class, right?
Most probably yes.
Okay, thank you then.
Sir, can you
Thank you
please
for the
share
session.
the Excel sheet for live sessions?
Sorry?
Sir, can you please share the Excel sheet
No, it's a
of
basic
live session
formula. It's basic formula, not Excel sheet. You can simply apply.
for live sessions, sir? Actually, in the portal, it's just available. The live session notes are just available till week 8 on the portal. After week 9, there are no live session PDFs on portal.
Okay, that's okay. I think we need to cross check. Actually, once one session I took, I forgot to save in my system, so that is not available with me as well. Okay, so sorry about that. But yeah, these PDFs I will share with the team. They will upload on the portal. Okay, so Excel is nothing but a basic formula. It's okay.
Sir, this PDF will be available in the portal tomorrow morning.
Yeah. I will share with the support team. They will upload. Anyway, I was shared in the Zoom chat. You can access from there
Actually,
for
I
now.
couldn't download it, sir, because of
That's
some network.
okay. Okay, not a problem. By tomorrow, it will be uploaded. Okay.
Okay, sir.
Okay, then. Yes.
Sir,
Yeah.
from where I can get the PYQs discussion session by TAs held on 24, 25, and 26?
Did you check your calendar?
Yes, sir, but it's not there.
No, it's not. I think you are talking about mathematics.
Yes, sir.
No, so for mathematics, please
In
contact
CC.
to math instructors. Okay, they are the correct person for
Okay,
this.
sir.
Okay, yeah.
Sir?
Okay. Yes.
Sir, are you going to take the sessions of stats 2 as well?
In next term, yes, I will be taking the stats.
Okay. Thank you, sir.
Yeah, thank you. Okay, do not worry about the stats. So it's a bit far. Okay, so we'll see it's later. Yeah. Okay. Okay. Then. Yeah.
Sir, will there be any gap after term 1?
Yeah, there is 20 days gap. Please check grading document. I would suggest please check IITM online degree. Okay.
Yes,
Site
sir, I
authority.
checked the grading document, but I wanted to make sure.
Yeah. So my answer will not be changed. No, it will be same from as because we have to follow the grading pattern also. Okay.
Thank you, Sharmaji.
Okay. Then yeah. Please. Yeah. Yeah. You are saying something.
He said thank you, I think.
Okay. Yeah. Okay.
Prashant
Thanks.
sir,
Yeah.
Sir, actually, do you have a sir activity sheets also, sir, for activity questions?
Right now, no. Activity sheet is?
I mean, the way I mean, we in Google Sheet, the maths one, like they have already posted all the I mean, graded assignments, questions, and as well as practice assignment and activity question. The way stats is all. I mean, in stats also, do you have answers for those activity questions?
No, we don't have answers of activity questions like this because we didn't giving. We are not giving the solutions of activity because it's very basic thing. It's based on lecture video itself. Yeah, but from the next term you will get the solution of the activity most probably. We are trying to.
Yeah, because from week 8, sir, actually I was solving today activity questions. So few of the questions I was unable to solve.
Yeah, if
So
you are unable to solve, that's you can simply ask what. That's no problem. Okay? We don't have actually solution. I mean, written solution for activity. Practice and all you can. If you click on check answers, you will get the answers. Okay, and for graded, you can check under the supplementary content. Except activity, we have the solutions. Okay.
Okay, sir.
Yeah. Okay.
Thank you,
All
sir.
right then. Thanks
Thank
all.
you,
I
sir.
hope you got the idea of this week 11 and week 12.
Yes.
And
Yes,
you
sir.
got the idea how to
Yes,
solve
sir.
the questions in your exams. Okay.
Yes,
Yes,
sir.
sir.
Yes, sir. Yes.
Thank you all. Thank you all.
Okay, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you.
Thank
Good
you so
night.
much.
Thank you for
Thank you,
this
guys.
amazing
Thank you,
session,
sir.
sir. Thank you.
Thank you.
Thank you,
Thank you.
sir.
Good night, sir.
Thank you. Thank you. Bye. Good night.
Good night, everyone. Good night, sir.
Good night, everyone.
Good night. Bye.
Thank you, sir.
So someone user is there. He's asking about his extract marks is showing 78 and now dashboard is 65. So this is not a technical glitch. First thing, second thing, I think I already mentioned a lot of time. There was a discrepancy in the marks, okay, given by peer.